Some analyses require an interpreter or group of interpreters to estimate the minimum, most likely, and maximum values for a continuous distribution. The triangle and beta distributions are ideal for modeling distributions under these circumstances, namely estimating with 3 points. One of the key advantages of the triangle and beta distributions is they don't exceed the minimum and maximum inputs, unlike the unbounded normal or log normal distributions. The triangle distribution doesn't have a built-in Excel function, but can be calculated with a rather long formula. Another disadvantage is that its variance is fixed. On the other hand, the beta distribution does have a built-in Excel function, shown here in the bottom center, but requires two shape factors, alpha and beta, that can be easily calculated. The PERT was developed in the 1950s to manage project timing as part of the Polaris weapons system. Hence, PERT stands for Program, Evaluation, and Review Technique, as described by Clark, 1968. The beta PERT shape factors are calculated such that the standard deviation is 1/6 of the range. Voss in 2000 modified the beta distribution so that the variance could be modified using a dispersion factor, lambda, adding greater flexibility to the shape of the distribution. Interpreters may not know what the dispersion or variance of the distribution is, so in addition to estimating the min, most likely, and max inputs, the dispersion factor lambda must be estimated as well. Two other advantages of the triangle and beta distributions, besides being bound, is that they can handle both skewed and negative values. And the beauty of the dispersion factor allows the beta distribution to model everything from uniform to log normal shapes. The effect of lambda, as demonstrated in the left-hand figure, uniform at 0.001, triangle at 4, and normal around 10. I've compared the descriptive statistics of the triangle and beta with a lambda of 4 that show almost no difference in the table. I've also included the descriptive statistics for the normal distribution. See how the min exceeds the minimum input of 75 and the difference in the standard deviation. Also note in the bottom left figure that as lambda increases, the range in beta distribution diminishes. With that said, let's look at the Excel workbook. In this Excel worksheet, we're going to look at the triangle and beta distribution. We'll compare the normal in blue to the triangle in red and the beta distribution in black. But first, let's take a tour of the worksheet. We have the chart here with the comparison. Here's where we put in the inputs for the most likely, the minimum, and the maximum. The standard deviation for the normal distribution is calculated here using the range rule. The beta distribution has two shape parameters, alpha and beta, which are calculated here, and their dispersion can be modified by lambda here. Right now we have it set at 4, which gives you a beta that has about the same dispersion as the triangle distribution. We've generated some descriptive statistics here based on 5,000 random samples. The heavy lifting is done over here on the right, where we have the probabilities, the normal, the beta and triangle values that have been calculated. Here we calculate again the distributions, the values and the densities for different probabilities. That's what is being charted over on the left. And here are some frequency and density distributions based on the 5,000 samples. So with that said, let's play around with this a bit. So the first thing we can do is we can change the lambdas on the beta distribution. So instead of 4, let's change this to 10. Enter Shift F9, and we get a distribution that's very similar to the normal. In fact, if we look at the standard deviations, we see that the normal standard deviation is very close to the beta. Now, let's change the lambda to 0.001, which should approximate a uniform distribution. And we can see here the black line shows a uniform distribution. Let's change the lambda back to 4. And let's play around with the symmetry. Right now, we have a symmetrical distribution. Let's change the max to 200 and see what happens to our charts. So again, Shift F9, and we see both the triangle and the beta are asymmetrical. The normal distribution stays symmetrical though, although it's going off the edge of the chart. That's because the normal distribution is always symmetrical by definition. We can also see the asymmetry over here in these frequency plots. If you want to dig more into the calculations in this workbook, I suggest that you download it. I'll leave a link in the video description. But you can easily check out the formulas by just clicking on the cells. And also, I've done a bit of a write-up down here explaining what's going on in this workbook. Thanks for listening.